divide a 3/2. We say, oh, just multiply a 2/3. You do it a lot too, because sometimes you get 5/2 and 1/2 and 3/2. Yep. Does that make sense? All right, now change the problem just a tad. Here's yellow. What did this problem have? Evaluate the definite interval. Now, what were the numbers? 1 and 4. So, if it's a definite interval, 1 and 4, 1 and 4. 1 and 4, 1 and 4, a 1 and a 4. And then, once I do the antiderivative, Amber, I don't put that dx anymore, do I?
No.
I don't. I don't have to put the plus what? Plus c. But I put this vertical line here, and I'm going to substitute what numbers? 4 and the number 1, and I'm substituting it for what letter? X. You start with the 4, right? So you get 8 times x to the 1/2, that means 8 times 4 to the 1/2, plus 4 times 4 to the 3/2. I'll put a big parentheses around it. And then what do I have to substitute up?
Negative.
Put a 1 in there, right?
1
to the 1/2. Plus 4 times 3/2. And what is between these every time?
Negative.
Subtraction sign of negative. It's always a subtraction, right? Put this in, subtraction, put this in. Now, how do you do these? You don't need a calculator. Your calculator can do it. Like 4 to the 3/2. It means the square root of 4 and then cube it. This means the square root of 4 raised to the first power. All right, let's start with this one. What's the square root of 4?
2.
2. 2 to the first power? 2. What's 2 times 8?
16.
16. Trust me, Owen, you can do this. Just don't, we're doing PEMDAS. You gotta do exponents before you do multiplication, right? Please excuse my dear Aunt Sally, order of operations. So let's do this first. Square root of 4 is 2.
2.
2 cubed is
8.
8. And then 8 times 4.
32.
Does anyone see that? Does everyone okay with that? It's the idea of something you can actually do mentally. Everyone in here, we all know the square root of 4 is 2, and then we all know 2 cubed is 8. All right, I got all that. Now I got to subtract. Oh, you got to love ones. Everyone, 1 to the 1/2 is a 1. 1 to the 3/2 is a 1. So it looks like our answer is 16 plus 32 minus this 12 over here.
36.
Yep. You got it. 48 minus 12, 36. Definite integral. We got a definite value, right? We evaluate it, we get a value. What does it represent? Well, that was velocity. That represents displacement, right? Right? You go, oh, it represents area under curve, but I gotta be careful with that wording because sometimes the function may go underneath the what? X-axis, and that gets subtracted out, so you can say the word net, N-E-T, for like net area. Right? And that's why this section, they talk about the net change theorem. This idea of net change, right? Net change, but that's what that is. That was the only one I thought it was weird. Did anybody see any other goofy ones in here? Or from the ones I assigned? If we do, would you holler at me tomorrow? Would you bring up that problem tomorrow? There'll be time to do that. There'll be time tomorrow, even on Thursday, to do some of these problems in the textbook that you're like, I tried number 11. I couldn't get that one.
So the test is not on Thursday.
Right, we're going to have it Monday. We're going to have it Monday. We thought it was a good idea. Everyone can take the weekend and just
It's a
go to
good
review.
idea.
Some students will probably start, they might start even prepping for the, getting prepared for the final next week, but they'll still know that they're getting ready for that test on Monday. They had that weekend to do it.
So the final is on next Thursday?
That's right. You could actually take it Wednesday if you would prefer to do that. The reason I like to do a Wednesday, Thursday option, there are many students in this class actually, this isn't their only class. They have another final on that Thursday. And isn't it tough, 2 finals the same what? Not only the same day, but back to back almost. That's wipe people out. So it's like some of them like to have that. Can I do this Wednesday? I'm going to prep for yours, and I'm going to start prepping for the next one, or vice versa. Cool?
Do your class on Tuesday?
Yes.
Yes.
Class would be Tuesday. That's a good day because that's review. That'd be a review day, review anything, We'll just be reviewing. I'm hoping that on Thursday I'll be reviewing for test 4. but I have a feeling a lot of students are gonna start asking me questions. You know, once they're like, I'm confident with the material in chapter 5, they might start asking me questions about like earlier tests and start reviewing early, and that's okay too. We can work that in. Cool? Alright. Alright, let's have some fun. This is awesome. Everyone, you remember chain rule?
Mm-hmm.
This is the only rule we learn in this Calc 1 course. You go, what about product? What's the opposite of product rule? We don't learn it here. I wish we could, it's fun. Right? It's called integration by parts. Well, we don't do integration by parts in Calc 1. We used to, they took it out. They put it in Calc 2. Alright. Kind of miss it, it's fun. If anybody in here wants to know integration by parts, let me know, I'll show you. But we do the substitution rule. But it's basically the reversal of chain rule. So it is by far the most important rule. Just like chain rule is like the killer rule, substitution rule. Like killer rule. So, let's look at one. We haven't needed the substitution rule yet. That's because everything we've done is so far been stuff like this. Or what? You don't have to copy these, you know, stuff like this. You know, these types of examples. We haven't had this, let me say that word, composite functions. We haven't seen any of those composite functions yet. So, here's my first one. Da-da-da. Evaluate. Hey, is this a definite interval or an indefinite interval?
Indefinite.
Evaluate the indefinite integral. Well, ladies and gentlemen, we need the substitution rule. See, the integral of e to the x is e to the x, right?
Mm-hmm.
Who recalls the derivative of e to the 2x?
2
2e
to
to the
the
2x.
Gosh, you're good. Seriously, that was good. That was loud. 2e to the 2x. Chain rule, right? Well, this is going to be like that backwards. So the answer should kind of be backwards. Would you expect that? Okay. Would you expect the answer to this be kind of backwards of that? You said the derivative is what? 2e to the 2. Let's see what comes about. What do? We do what's called the substitution rule. And appropriate letter, we got to use a letter other than x because we're going to do a substitution. So in calculus, we like to use the letter u. And that's why we call these u cells. Alright, so we're going to let u equal something. We do it off to the side. So let u equal something next expression. Well, I'll give it away. This is the first one we're doing. We're going to let u equal to 2x. So what is u? If you wonder what is u every time, it's usually something under a radical, or u is something up in the exponent, like here. Maybe something in a parentheses in a problem. But through experience and through practice and through the problems we work in class, you'll get used to it. You'll know how to find or use, or excuse me, identify what you should let u equal to.
Is it like the same thing as a g?
Yes, it is. Because it's just like a g. And we're going to be doing it backwards. It's just like a g. We could have called these g subs. That's exactly right. That's exactly what it is. It's just like that. So I'm going to let the u equal to what?
2x.
The 2x. Because it is. It's like composite function. E to the 2x, like e to the u.
Oh.
Now, that's step one. But it's always a three-step process off to the side. So, for the next hour, get used to this. Step 1, step 2, step 3. Sometimes you can complete it in 2 steps. We'll talk about that. Step 2. Now that you let u equal to something, differentiate both sides with respect to x.
So du over dx equals to 2.
Du over dx equals, what's the derivative of 2?
2.
2x, excuse me. 2?
2.
And du dx, now I'm going to erase this. Does everyone have a pencil? I want to show you how we're going to write step 2 every time. It's appropriate to write this actually as the differential du. So I can put this dx next to the what? 2. So do you agree du dx, the derivative of u with respect to x is a 2? But every time in step 2, we're going to put this dx here. We're multiplying a dx on both sides. We're going to consider this du equals 2 what?
dx.
Yeah, we'll do that every time on step 2, every time. So you'll get used to it. You go, all right, du dx is 2, but it means du equals what? 2 dx. Leave that dx over here on the right side. Now, step 3, I'll be clear on this step. What are you doing this? Notice this is off to the side, by the way. You notice this? I'm not working the integral yet. We're gonna come back to this. It's like I'm off to the side here. In step 3, if any constant emerges on this right side, I want you to divide it. I want you to divide it on both sides of the equal sign. So 2 emerged, right?
So half
Let
of
me say it again. You'll get used to this, but if a constant just emerges, any kind of like a 2, a 5, a 3, it emerges there, we're gonna do what? We'll divide it. Now what if a variable emerges? No, I don't want you dividing it. Okay? Now you'll get good at this, and you'll be able to play with this even more. But you want something that works every time, you're like, okay, any constant pops up, I will divide it on this side. Oh, go ahead.
I didn't want to do that if that's not okay.
Oh, so if there was no constant there, just like an invisible 1, or 1 was a constant, then we'd be good to go, and we'd go substitute. Good deal. Hey, and make a note, Josephine, what if variables popped up over here, like x's and x squareds and x cubes, things like that? Variables, leave them here. I only want you to divide into what? A
constant,
constant. So what would this be? What would dx equal?
half of du.
Half a du. Some of you may say du over 2, but I like that. I like the way you said it. I like the half of du. So 1/2 du. So here's the 3 steps. We'll do it over and over and over again. Now what do? We substitute. So it's a substitution. What do we do? All right. We'll start with this guy. So I'm going to box him. That is going to go replace the what?
2x.
2x. Let me say this again. This u is going to come in here, right there, and replace, substitute for the 2x. So maybe I'll take an arrow and go, here, you're coming in. Right there, and what are you doing? You're going, what am I replacing it with? U. Cool. And then, this guy, in step 3. What's that replacing?
dx.
That's going to replace the dx. And what you notice is we're changing this whole problem and putting it in terms of u. Okay? So this will replace the what?
Yeah.
dx. So now remember the dx is important. Right? Before we were just like, gosh, we just wrote it every time. This is with respect to x and these integrals. This is now going to replace this. Now everything's going to be with respect to u. The only thing I got to make sure when I do this, you're going, I'm putting what here? 1/2 du. Now I'm going to write it, then maybe I'll change this. Look, 1/2 du. Does anybody have a suggestion where I should put this half?
All the way to the left.
I think it's a great idea. When you get these fractions like this, like a half or 3, you might find it easy just to put it way over here in front of the integral. Because doesn't it look weird over there?
Mm-hmm.
It does. Like this e to u, half to u. I recommend taking this half that's sitting right here. I know it's right next to it, but I can put it over here. And then now have just what right here?
1/2 plus e to the u.
Let me write it again. You said what? 1/2.
S e to the u.
Now I want you to glance over this to make sure we didn't make any mistakes.
Do you have?
I shouldn't have any x's left in that expression. Do I have any x's?
No.
That's the idea. I've now substituted. Everything's in terms of u.
Now why'd you put the du?
Oh, that's important because every time you do an integral, it's going to have like du or dx or dt, right?
Yeah.
All these are Amber. We'll over and over. We'll use u. So we always have this du there. Sterling.
What's the S called?
The s, it's an elongated s, right? And it's just the integral. This means that we're finding the antiderivative. But it's this is elongated s because it did find like the Riemann sum of all the rectangles that we were doing earlier. All right, and what's the integral v to u?
e to the power u.
E to the u.
E to u. Oh, the integral v to x is e to x. What's integral v to u? We have manipulated this problem so we can integrate it. That's what we're doing. That's the game here. So look. Integral v to u is e to u. What about the constant? Constant rule. Leave the constant in front. But this was an indefinite integral. I have to put a plus what?
C.
Plus c. It was indefinite. Now,
No.
this was step 1. If this was step 2, if this was step 3, and if step 4 was substitute, step 5, resubstitute.
Can I ask you a question?
Yeah.
Now this half, shouldn't it be also go to C also because do you have to put a bracket around it?
You could if you want.
Okay.
Hey,
Why'd you take
that's a
that
good question. He goes, should I put the half to C too? You could if you want, but this is an unknown constant. So half times c is the same as some unknown constant, what's
Got
c?
it.
So I couldn't take off, Art wrote half c here. I mean, yeah, it's some unknown constant, half times c.
Why'd
You could do that if you want, but you can just put plus c.
Got you.
Why'd you take out the s?
Oh, because we found the antiderivative.
That's it.
Yep, because we integrated it. The integral v dx, e dx. So the integral v du is e du.
The s was to, oh, it's
Integrate,
like,
yeah.
You got it. Now, I want step 5. So I'll review this, right? Step 1, boom. Step 2, boom. Step 3, boom. Step 4 was substitute. Step 5, resubstitute. We can't forget this. It's important. This problem originally had what letters?
X.
I cannot leave my answer like this. It originally had x, is the final answer has to have what? So I have to resubstitute. You gotta go back, earlier in your work. What did you let it u equal to and resubstitute it? What was u?
2x.
So the final answer is 1/2 e to the 2x plus 1. There it is. Now how could you check this? You should be able to check every one of these.
It's half of,
Take the derivative of this. You should come right back to this. E to the 2x. Isn't that cool? You can check every one of these. So when you see something going on here, we said the derivative with respect to x of e to the 2x by chain rule was 2e to the 2x. Well, what was the integral of 2x dx? What did it come out to be?
half of the,
See how it's almost like opposite? And a lot of you will see patterns like this, and you'll be like, I don't even have to show work, I know what this is. And that's actually a good sign. Can I give you an example? What if I gave you the integral of e dx, e to the 3x dx on the test?
so 1/3 it,
130.
I heard it. See how loud that was? You're like, it's just gonna be 1/3 e to the 3x. You got it. Oh, question?
That's all, that's what
Oh, good. Hey, so yeah, you go, then I have to show any of that work. Because I'm so confident I know that's what it is. So if I gave you, ready? Integral of e to the 5x.
1/5.
That's what you would get. I think it's great. I think it's super when you're like, I know what'll happen.